So if you're watching this video, you could get this short URL, DE5QSL. I'm recording this, by the way, in case you guys want to look back at it or anybody else in the world wants to look at it. And when you click on that link, it's going to take you to the syllabus for my Advanced Web Programming class at California State University, Fresno. And which I don't recommend ever going to that town. I'm trying to get out of it. Seriously, it's crap. But here are the presentation slides for building web apps with Go. So that'll walk you through the whole deal. And then here is the presentation code. And you know, I'm only 9 months new to this language, so I don't maybe write the most outstanding code. And as I learn more stuff, I realize, oh, I should have been doing this a little bit differently back in the day, 4 months ago or whatever. So, but still, it's a pretty good pathway for giving you like, how do I learn this language and how do I start doing web apps in this language. And so there's that code. And then there's a bunch of other resources here that you can look through, including a bunch of index videos and videos from a summer web boot camp we put on. We hired Caleb Doxey, who's the author of this book, to come in for a month, and he's awesome. He was black belt programmer, kicked my ass up, down, north, south, east, west, all day long. I got so burned out, ripped up, torn apart. Yeah. But luckily,
the fastest person we've ever seen.
Yeah, the best, right? And luckily, we recorded all the videos, so I've been going back through and watching them, and that's where I'm putting together all my presentation materials. So I got the resource that I'm delivering to you. I got it from high up on the mountain, and then I brought it down, and I'm repackaging it for the common man. I've taken what the gods of programming have shared with me, and I've reflected and meditated upon it, and now I've sort of like, you know, so when Caleb would convey something in like, 7 minutes, like, I'll literally like take that apart, and it'll take me like 3 hours to write the code, and put together my presentation that fills in all these assumptions and jumps he made, and so anyhow, it's pretty awesome. But all those resources are there. So we already looked at getting our Go environment set up, and to do that, you just download and install Go, and then you got to make sure that you have a workspace. And your workspace is just a folder where you're going to keep all your work. Inside your workspace, you need 3 folders. You need your package, you need your bin, and you need your source. And so just so you can visually see that, I called my workspace Go. I actually recommend calling it Go Workspace. Just have one workspace. That's it when you're starting out, right? And so you have your Go Workspace, and then you need a bin, a package, a source folder, and then inside that, this is the namespacing convention in Go, and namespacing allows you to do all kinds of package management. So you're getting packages from others, you're sharing packages with the world. How do we do that? We do it with a namespacing convention, which is domain, username, and then folders where work is collected, right? Or packages, or whatever you want to call it. So my GitHub.com, my username is goes to11. And in here is the Golang training, and so that's one of the places where I keep my work. There's another guy, Julian Schmidt, who has that's his username on GitHub, and he has this HTTP router package, right? And so I downloaded that, and this is where it stores it in my workspace. So I always have that code. Julian Schmidt could delete his repo. That code's now on my machine, right? And so it's just a really easy way to namespace stuff, and you could use different domains up here, right? But this is the common convention. And that's how you need to set up your workspace. And then once your workspace is set up, inside terminal, you could do Go version, and you can see, hey, I got that version. And you could do Go env, and you'll see that you have your Go path. Absolutely important, porting towards that workspace. My workspace is in Documents, and it's called Go. It's right here, right? So you need that workspace just like that. And then you need your Go root, which automatically should be set upon your install, and that's pointing towards wherever the Go SDK, Go binary got installed. And so that's everything you need to sort of get going with Go. And the one thing that we've already covered is that here in presentation slides you have editors. And so we've configured our editors to run WebStorm. And I go through all of like WebStorm. Wait, I didn't actually open that up. Let me go into editors. And slide, I got to do it right here. Oh, pause. There we go. Is that now? There we go. So this shows you through how to set up WebStorm, including you want to go and download, just search at Google for WebStorm Golang plugin. And then you'll install that. And when you go here, you want to make sure you get This is not the fastest website. They need to rebuild it in Go. That's my recommendation. You go here and you choose Show All Updates because this one's a year old, and when you choose Show All Updates, you'll see the most current one. That's the one you want to download and install that one. And you install that in WebStorm, right? And when you first start WebStorm, it asks you for an area where you could go into plugins and add that in, which brings you to this area. So you'll totally see that when you get in there. All right. That's all the setup, and that will show you how to use WebStorm, that presentation. And so what I want to do now is actually just kind of like fast forward past like all these presentations, and I wonder if I could do that layout here where they're laid out instead of as squares. I can. There we go. So I want to just jump past like all of this stuff, right, which starts teaching us all the language, and we could come back and look at it because I'm presenting this to two developers who seem like they're pretty skilled. And so we're just going to look at like jump right into the deep end, and if we need to go back to sort of figure something out, we can jump back and go. But let's just kind of see what you could do with it. And we'll do that by looking at code. And so this is live coding, and like I said, I'm 9 months new to this language, so I'm not an expert, so sometimes I might like hit a wall or something like that, or it might take us a little bit of time to figure something out. So just be forewarned. And I want to open one other thing to kind of look at, because I did this one which was pretty cool, and I think it's a great example. And so let's just walk through that. And so here I have a text file, right? And this is my text file. And so it's got 114,774 records, and I just want to calculate the mean and get the median. Okay? And, sorry, let me go through this. That's the solution. And so the first thing I want to do is I just want to open that. Great. And I open that and I get a file. Now right in WebStorm I could hold down Command and I could hover over stuff and I could click on it and it'll take me right to the file. Open takes in a name, and so I could see, hey, open took in a name to the file, and it returns a pointer to a file and an error. Okay, so pointers, if you haven't worked with pointers, I got a presentation which totally talks about that. We could go look at that. Everything in Go is passed by value. There is no pass by reference. When you pass an address, you are passing by value. And the value you're passing is an address, right? And so, as much as possible, stay away from like, there are definitely times when you use them, but you want to know like that isn't something you just willy-nilly throw around. Only use it if you need to use it. I know that doesn't really say much, but you don't want to just wildly make everything references. And, because a lot of things are already references, right? There's reference type. So why are you making a reference type a reference when you're already passing the address? Because it's a reference type, right? So you just have to think about stuff. And so here's my pointer to a file. And so pointer to a file is a struct. We have a data structure in Go. So there are arrays in Go. We don't really use them when we're programming. Right? Arrays are of fixed length, and that's it. And if you want another one, you got to create another one, and that's expensive. It has a cost, right? Processing cost. And then there's slices, which are built upon arrays, and slices are like lists, and slices can expand and grow, right? So you can set the original length of the slice, and you can set the capacity, and then when you reach capacity, so let's say I have a slice, and I want to store 50 things in it. So I say, hey, the original length is going to be 50, and the capacity is 100. Well, I get to 101, it just grows. Now it's 200. My capacity just doubled for me. So it does that automatically. But slices are built on top of arrays. So when it does that, it's building a new array, right? So when I originally create my slice, if my capacity is 100, I have an array beneath that with a capacity of 100. If I go to 101 in my slice, that original array, a new array of twice the size gets created. The original array of 100 stuff gets put into the new one, and then I got 100 new spaces in that array, and my slice is sitting on top of that, right? So we have arrays, we have slices, we have maps, which are just like key value dictionary type of deals, and then we also have structs. And so structs are structures, data structures, where we could put fields into them. And so here you see a struct that has a field, and the field is a pointer to a file, right? There'll be other structs. And so, here's another struct, right? And it's got 4 fields of different types. And so that's kind of like when you start to do a comparison between this and other object-oriented languages. You say, oh, okay, I'm kind of sort of creating, my class, and then I could create instances from my class. But we don't really use the terminology in Go of class at all, and we don't really talk about instances. instead. And Go has a language all its own to talk about the language, right? Like everything, like if you become a construction worker, it's going to have a language to talk about construction work. People will be like, hey, why don't you go get me that, I don't know, I don't have any construction phrases. But if it's surfing, it'd be like, dude, bring your gun, it's big, right? And if you're a surfer, you know what that means. But otherwise, you're like, what? Why did I bring a gun? I thought we were surfing. No, a gun's a big board. Because if you're going to hunt big elephants, you need a big gun, so they call it a gun, right? But everything has its own idioms. And so Go has a language, talk about the language. It's not classes, it's not instances, right? It's types and structs, and I create a value of this type, right? I created a variable of this type and stored this value in it. So you just need to think about things as variables, types, values, variables, types, values. I created a variable of this type, and I stored this value in it, right? You don't say instance, though you probably will, but it's a hard habit to break. And that's like with 92% certainty that I share that with you. But I know it's absolutely correct to say I created a value, I created a variable of this type, and I stored this value in it, right? So I have a struct, and that struct is a type. It's a type. I created my own type. Like, have you ever worked in a language where you could create your own type? Like, there's ints, there's strings, there's bools, and then there's type Todd. I created my own type, and it's like ints, strings, and bools all together. It's got 3 fields, one of each. It's type Todd, and then I could create a variable of type Todd. What? Have you ever worked in a language where you create your own types? Yes?
Yeah, see.
See? You can do that?
See, and also like in terms of objects, right? So you can also kind of visualize object as a type, like meaning an object. You can have properties of the object represent different types, and if you create an instance of that object, you are creating a variable of that type.
Yeah, it all becomes like a mind thinking, like how do we actually like hold this logic in our head? But yeah, so however you want to think about it, but this is the way we talk about it in Go, okay? And I created a variable of this type, and I'm storing in this value. And so structure is sort of like an object, and it allows us to collect different fields, and figure out what the state is, if we create a variable of that type and store a value in it, right? And then we could also attach methods to types, any type. We can attach a method to any type, though really we kind of, mostly do that with structs, all right? And so that really sort of becomes our AKA EG object, where we're able to create instances, but we don't really say that. We say, hey, I created a variable of this type, and I stored that value in it, all right? And so, gives me a pointer to file and returns an error. What? 2 returns? You can do multiple returns on functions in Go. Well, that's pretty cool, right? But pretty much you don't. This is the only way you pretty much see it, is you're returning a value and an error. And this is how error handling's handled in Go. You deal with it right then. You don't put it off, right? You write your code and you write error checking at the same time. There's no later like, okay, now I'm going to do all the error checking stuff. It's like you pretty much want to be doing that right when you're writing your code. Like, hey, this could be returning an error right here. Okay, let me write the test for that. And if something goes wrong, I'm handling it right beneath it. You want to write your Go. Go was written. If you look at like why was Go written, right? Like Google Golang announcement. I don't know if this will bring it up. Google announcement. I don't remember where I got that. Golang released. Whatever. I have it right here. It is in. I'm going to put it in this presentation. No, I didn't. I put it right here. I was going to put it there, and I put it right here. No, I put it right here. Sorry. Here at Google, we believe programming should be fast, productive, and most importantly fun. That's why we're excited to open source an experimental new language called Go. This was in 2009. And this is really a great time to be learning about Go because 1.5, which was just released like a month ago, and what is this? This is October, so it's like beginning of September or August of 2015. 1.5 was like the 5th release of Go, right? 1, 2, 3, whatever. And it's like the language is now complete. The standard library is now complete, right? And in 2013 was the first time, I think, was when 1 was released. So it's only been around like 2 years in a finished version, and now it's completely finished in 2015. So very good time to be learning it. And this presentation shows you all the different companies who are using Go, and you can see like massive big names, and it just goes on and on and on, and it continues to grow, right? So all kinds of. And it also talks about why Node.js sucks. Sorry, I can't help but to take some shots. Since some of the primary contributors to Node.js left Node.js for Go, right? And these articles talk about some of those primary contributors and why they left. And so, to hell with you, Node. We're taking you on. All right, that's my proselytizing right there. This is a good book, too.
So I have just a question. So there's a part that I kind of look at the online training.
Yeah.
Before coming in here. They said there's a compiled version and the script version. So what's the difference? Do you have a object?
No, Go is only compiled. It's a compiled language. There's no scripting, there's no interpreting, there's no virtual machine. It's a compiled language. It's statically checked. This is a low-level systems programming language that has a great standard library that lets you do a lot of high-level things, and it's awesome, right? And so there's no interpreting, there's no virtual machine. Everything you want to run, you compile it and look at it. But it compiles like an interpreted language, right? So that's one of the things that little announcement right there said is, right? That's why we're excited. Go combines the development speed of working in a dynamic language like Python with the performance and safety of a compiled language like C or C++. Typical builds feel instantaneous, even large binaries compile in just a few minutes, seconds, and the compiled code runs close to the speed of C. Go lets you move fast. So it's like working in a dynamic language or a scripted language, right? Or an interpreted language, whichever way you want to kind of look at that. So maybe that's what you heard, is it's like it. But or that maybe there's something I don't know. But I think I have like 99% certainty when I answer that it. Yeah. All right. So I don't know what the hell I was talking about. We were talking about types and structs and then methods, and so multiple returns. So this is one of the things you could do is multiple returns, and that's kind of cool. And you handle your error checking right then. And so when I look at that, right, I open a file and I get the pointer to a file back and I get the error. Well, let's look at the docs. So if you look for Golang and what is that coming from? That's coming from the OS package. It's the standard library. You can see I imported the OS package. I can click on OS and it takes me right here to the OS package. Whoa, cool. I got all of the source code for the entire SDK for all of the Go language right there, right? For all the standard library, it's right there. I could go in and I could be like, hey, how does error Go work? And this is the code that the geniuses at Google wrote. I could see how are they writing it. This is the best example of like how you should be writing your Go code. So you can look to Go's standard library to see how you should be writing your stuff, right? So really good reference. And then also just to look things up. It allows you to work quick. That's one of the things I really like about WebStorm. Oh, how's that work? Bam, 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 bam. And I just go right through all of the standard libraries, see how everything's connected, and then I'm able to, get my little Lego pieces and put them together to build my little sandcastle, right? So here, sorry, I drank too much caffeine. If I want to learn about Golang OS, right, I could type Golang OS, and it takes me to golang.org package OS. Okay, cool, I could go to that, and this is what that looks like. Well, somebody else said, well, that's great for the standard library, but what about all these other libraries that people have contributed, right? Like you could search for stuff. How do we find those things, right? There is gosearch.org, and you could search for Go stuff here. So maybe I need something with a universally unique ID to do sessions, right? I could search for that there. I don't use that very much. This other guy created this thing, godoc.org. I could search for UUID at godoc.org. Boom, 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 boom. All these packages that other people have written. Right? And it's like, cool, which one do I want to use? I think they're ranked in order of like goodness, I'm not sure how goodness is determined, but it seems like the ones that you should be using usually come up near the top, right? And I think maybe goodness is determined by looking at how many people are using them by going through GitHub and seeing how many people are actually using this. And so I think that might be how they're determining goodness. But we'll see new 7 hatch go UUID, right? And so awesome. If I want to use that right here, like let's say I want to use Satori go UID, I have no idea who this guy is, so I'm actually not going to use a go get. Because maybe it's a good idea to look at that code before I go get it, because now I'm going to actually download code and install it on my machine, which means it's running, right? So I don't want to install it. It gets run and compiled and installed. I don't want to do that if I haven't maybe taken a quick glance at the code, make sure there's nothing stupid in there, right? That it's going to immediately start sending my files over to him or something like that, right? But you probably want to be ranked at the top of goodness. But just FYI, you are playing with knives and fire. You're in the kitchen. Don't cut yourself and burn yourself. Right? This is no longer like kitty daycare PHP, right? Or, whatever other comparisons you want to make. All right, so here's where you do it. And notice the name spacing, right? And so I could go right there, and it's going to take me to this, and I could read about the documents. So not only are these documents here, there's Golang, right? There is Golang.org, which is the official, right, the official source for the standard library. And then there's godoc.org, which has the standard library in it. I could say, show me OS, and it takes me to OS, and that's the standard library. Or, don't know you. Or I could start looking up other stuff, right? So with that other one, it's like here I'm at this one. So it's everybody's documentation. The documentation gets built for you automatically, right, from your comments and from certain ways that you build your code. And then you just automatically have documentation, really nice documentation. And so there's certain idioms that you use to make your code a certain way, and then it builds this nice documentation. So the thing I wanted to show you was we were looking at os.open. Okay, so how does that work? os.open. And so here's a description of the package, and then I could do open, right? And I could come down here, and I have an example. And then, I could read more about open, right? Open gives me a pointer to a file. So there are my returns. Well, if I get a pointer to a file, these are all methods that I can now use, right? Because they have what's called a receiver, right, in Go, and that's a pointer receiver right there. And so when you have a type, you can attach a method to it. This is how you do it. A function is always a function until you attach it to a type, and then it becomes a method. And the way you attach it to a type is you use this syntax right here, and that syntax says, okay, this method is now attached to anything that is of type a pointer to a file. So when I get a pointer to a file from open, I now have all of these methods. One of the methods is close. You open a file, you want to close it. What happens if I open a whole bunch of stuff? Right? It's going to be like jamming up my CPU and my memory. So you don't want to just randomly go opening files and not closing them. You know this, right? Basic programming. So I open my file, and then I'm going to close it. And there's a keyword in Go called defer. And defer means defer this. It means defer. Like, I love Go because they don't make things complex. They actually take things that used to be complex, and they're like, we're not calling it that anymore. We're going to call it this other word, because that is more precise. That more accurately describes what's being done. I don't have an example off the top of my head. The first one that comes to mind is we don't do casting in Go. We don't talk about casting. We do conversion. We're converting something from one type to another. What the hell is a cast? Like, are we talking about some social system in India? Are we talking about a broken arm? Right? Why the word cast? It's converting. We're converting from this type to another type that's more specific. We're calling it conversion. Right? So, defer. Hey, we're deferring it. And I really like that about this language. Anyhow. So defer means I'm going to, right before whatever function I'm in, right before we leave that function, that's when I run whatever I've deferred. So right before we exit func main, everything that's been deferred runs. So right before we leave func main, I close that file. And it's nice having this right here because that makes for really great readability. Write a story. You want to write a story. Computers speak in words and pages. This is like built from the hippies, right? And humanism. Tell a story with your code. Make it easy to read. Don't be complex. These are the idioms of Go. Right? Keep it clean, readable, succinct. We don't want a lot of garbage. We don't want doublespeak. We don't want like public, static, void, main. Like, holy cow. And then this, and then object is like, what the hell's, what, why, what? Are you stuttering? What is all that stuff? Right? Like, no, tell a story. And so that's like, you put defer right here. You don't put close file way down here, because that's not close. It's like, oh, did I close it? Scroll through 20 lines. Okay, I did. Right? You open it, put close right next to it. It's like, I like that. So we close our file. And then here we're passing our file into a new reader, and that's from package CSV. Well, what's new reader do? Let's go to package CSV, and you might be like, CSV, what the hell? I thought I could just type that in. What's the namespacing? And actually, if you look at like this, right? So let me do here CSV. CSV is in encoding, right? And so you might not find it right here. What I needed to type in is encoding CSV. But I could have just done Golang CSV, right? And then I would be like, Golang CSV, oh, it's encoding CSV, right? So sometimes you have stuff that has like two things to it. And you just kind of figure that out after time. So here's my encoding package CSV, and I said new reader. And what's a new reader do? Well, I think maybe it might do some reading. I don't know, just a guess. Right? So I got a file, I want to read it. Give me a new reader. Right, and it does take a while if you're getting used to this library to figure out. And if you had some other experience, particularly in C family language, you're going to be like a lot of transferability between what you know and how you do stuff here. But if you're new to it, you're kind of like, how did I know I would have done a reader here? And that just takes a little time to figure it out. And so it said new reader, and it takes an IO reader. Takes an IO reader. What the heck? I thought I had a pointer to a file. What's an IO reader? So I click that, right? And I open it up, and I click this, IO reader. And an IO reader is from package IO, input, output. And a reader is an interface, and it has this method. So, right, you've worked with abstract, whatever, in Java, and you have interfaces also in Java. And, an abstract class is something that has some abstract methods, and an interface is something that has all abstract methods, right? Isn't that how you say it in Java? And that allows us to sort of do some things where, hey, if something implements this, then all kinds of things could use it, and we start to do polymorphism, and like all of these sort of like, it takes a year or two of introduction to computer science, freshman, sophomore year to wrap your head around all of that. But, right, it's like, what it is like, I like the example of like vehicles. Police officer knows that if a vehicle goes through this red light, I can pull him over and give him a ticket, right? And what implements the vehicle interface? Bicycles, cars, trucks, hell, planes, right? If a plane went through that red light, I'm pulling it over, right? They all implement the vehicle interface, right? And so it's the same thing, right? Anything that implements the reader interface, when we have something like this, hey, I take a reader, right? If that said, hey, I take a vehicle, great. I could stick a plane in there. I could stick a truck in there. I could stick a motorcycle, a bicycle, a skateboard, whatever, a boat. They all implement the vehicle interface. If that asks for the vehicle interface, I could stick any of those types in because they implement the vehicle interface. The vehicle interface, if you were to actually think about it, it's based upon what that object does, right? What that type does, right? It's like, well, that type takes things from one place to another. It's based upon what it does. It's based upon methods. And so here we have an interface that obviously is based upon a method. And so if it has this method, the read method, which takes a slice of bytes and returns an int and an error, if we have that method, then anything that has that method automatically implements interface. You don't have to say stuff like implements interface. You don't have to add that. You just need to have that method attached to a type, and then it implements that interface. And you can now use that type anywhere that interface is required or asked for. Right? So cool. Well, we are in our code. We have a new reader, which takes a reader, IO reader, and it's taking a file. So that means file must implement that interface. So if we go back and we look at a file, which is from OS, right? And so we'll go. Well, here I'm in package OS. Here, if we go look at I like GoDoc. I'm sorry. I'm used to GoDoc. I'm not gonna. That's the last time you're gonna see Golang package, Golang.org packages. I'm doing everything GoDoc. But if I look at my type file, it needs to implement the read interface. Bam! No, sorry, hold it. Bam! There it is. Implements the read interface. It's a reader. I could use it anywhere. A file is a reader, which means that, right, file implements the IO reader interface, which means that anything that takes an IO reader can now take a file. It's going to read that file, and it's going to return a pointer to a reader. I have two methods, which are pointers to readers that, attach to, which have a pointer receiver. I have two methods which have a pointer receiver of a pointer to a reader, and those two methods are reader, read all, right? And you can look at those to figure out what the difference is. And so anyhow, in my code, I say CSV new reader. I get my reader, which is a pointer to a reader, right? So reader, CSV. Reader gives me a pointer to a reader, so that's a pointer to a reader. And I do reader, read all, I read it all, and that gives me rows, okay? Because if you look at read all, it's slice. What? Here's slice, string, a slice of string. A slice is a list, right? And here's a slice of strings. Check out my data. So first time through my data, right, if I was to take some of this data, this right here, right, could just be one big long string. Everything I highlighted, that's one string, right? And then I could store those in a slice, right? So I could have, if I had a slice of names, one entry in the slice at index position 0 could be Todd. Another entry, index position 1, Eunice. Another entry, index position 2, Paul. Another entry, index position 3, Eugenev.
Yuvaraj.
You gonna say it again?
Yuvaraj.
Yuvaraj.
Yeah.
Yuvaraj. There we go, right? So that's my slice. So that's like one entry. And now if I have a slice of strings, right? Like if I broke this one up into here's a string, 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 that could be a slice of string. Whoa. That could be a slice of strings, right? And then if I want to keep that slice of strings in our slice, I would now create entries in another one. So this is how, you guys already probably know this, but just thank you for humoring me, for anybody who's watching the video, right? Well, I need to be at the documentation. Hold on. Right there. That's the one I want. So this is just going to give you like the names, slice of strings, right? Just a collection of different names or whatever text values I want, slice of strings. This one is going to give me something like a spreadsheet where I now have records or a database table. So this first slice of strings, right, would just be names or entries, right? Like, we'll do names. I kind of like God, actually. Right. So there we go. And now I could have like, okay, cool, I got a slice of strings. But now what if I wanted to keep a whole bunch of records? So I have one of those, another one of those, another one of those. Well, I'm going to need a slice of strings, right? And then this one here is going to store each one of those rows. I hope that makes sense. That makes sense to you?
Yes.
That makes sense to you, Paul?
So it's like a double-dimensional array.
Multi-dimensional array, yeah. There you go. Thank you very much.
So, I think I missed in the beginning. So, what's the difference between an array and a slice?
Okay, a difference between an array and a slice. That's a good one. Array is really just sort of a type that we use to build other types. We don't really program with that, right? It's more of like that was taken care of by the people who created the standard library. We use slices. So a slice is built on top of an array. Slices are dynamic. Arrays are fixed size, right? And so, there's a great article that I was just reading last night when Golang blog, which is an official blog written by Rob Pike and other people who built the language. And if you do Golang blog array, I was just reading this last night. And it talks about, hey, when we were creating the languages, we had to answer these questions. What do multi-dimensional arrays look like? Does the empty array have meaning? Is the size part of the type? Fixed size or variable size for an array? And they were really kind of like, I don't know, how do we best want to do this? And they didn't really get it right until they said, okay, we're going to create slices. The slices will be built on top of arrays. And it's just, I think some of the decisions for that had to do with performance, and I don't know what all they were thinking of. But here's how we'd create an array. So whenever you see a syntax like this with some value in it, that's an array. That's an array of 512 bytes, and it's storing a byte at each location, right? Or we could have had 512 int, or 512 string. That's an array. And then a slice is the syntax is like this, right? Right there. That's a slice syntax.
So slice is flexible in a way that we don't need to know the length of the collection. So it can be dynamic. Like it
Sure.
can be how
Yeah,
we-
just starting out, when you're coding, you could just say, I have a... That's fine. Okay? And then you also have something going on there. Just looking for length and capacity. Here we go.
You're asking fields to make a slice of string that has 3 variables or 3
Length of 3 and capacity of 5.
capacity of 5.
Yeah, so we set a capacity, and capacity is basically telling the compiler, look, I'm originally going to store 3 things here. However, I want to have the underlying array be created to size 5, so that if my slice grows, that array doesn't have to be destroyed and a new one built, right? And so if you know, hey, something's going to grow, then let me create the size for the slice to grow into that underlying array. And if it's not going to grow, so what happens when I exceed capacity? Like here, I've got a length 3, capacity 5, and that's just the syntax for making it this way, right? I've got 1, 2, 3, so I've used up my length, and I put in 1, 2, 3, right? And then here I append, and you can append, and that becomes item. Well, sorry, 1, 2, 3, 4, 5, 6, 7. So my length became 7 because I appended more items, and my capacity doubled. It went to 10. Your capacity, when you reach capacity, is always going to double until you get up to like 1,000 or 2,000, and then it increases some percentage, right? They have an algorithm for that, which sort of figures it out. But the code sample I showed you for Arden Labs, GitHub Arden Labs, Go training. He slides, and then that might be day 1, slices, and slices pending reference declare and length, so maybe under declare and length. And this code here is great to look at for code samples. So this guy who did this is really on it. Let me see which one. That's not it. He has a sample in here that really kind of shows that algorithm as you get up past 1,000 or 2,000. So it's somewhere in here. You can take a look at it. Maybe this is it, 3-index slicing. No. Anyhow, back to staying on track.
Make is a method that makes slices.
Yeah, so there's make and then there's new.
Okay.
And when you use new, here is the mnemonic device to remember what new does, all right? I got a new dog, it's a pointer, and I named it 0. My new dog is a pointer, and I named it 0. New gives you a pointer and sets everything to its 0 value. That's new. Make is for slice maps and channels because there's like underlying things that the compiler, the program needs to do to create a slice. It has to create that underlying array, right? It has to do some setup. And so make is only for slice, channels, and map. So make, and I'm going to pass in length and capacity, right? So I don't know, man. It's just like subtle details, right? But the main things to be taken away here is like I'm trying to convey just reading the docs and interfaces and types, right? And creating your own type and structs, holding fields and kind of like being like methods, and then kind of like being like objects and being able to attach methods to it with a receiver, right? And then knowing like, oh, I could pass this in. So this is a reader, so I could pass it in. It gives me a pointer to reader, and then I could do read all, and it gives me all of my rows. And then I could use this syntax. There's only the for loop in Go, and so when I look at like there's the Golang spec, and that's one place you want to look for how do you write stuff. And then there's also a document called Effective Go, and that's the other place that's official, where you want to look to see stuff. So the Golang spec, and if I look at the Golang spec for or iteration or loop, iteration, loop, let's just see, it should just be right up here. For, wow, you want to highlight your browser, search for for statements. Okay, so here we go. Wow, I got a lot of description there. I actually have not read that quite yet. I totally need to. And then here's another one. And notice how I went both to the spec and to Effective Go. And sometimes I like the way they talk about it in Effective Go better than spec, and sometimes I like it in the spec better than Effective Go. And so here is in Effective Go, and here are your for loops, right? We've got for int condition post, just pretty much your normal one. And then we have for condition, just put some condition in there, some bool, right? And it's going to loop until that condition changes. And then we have then we have just for, like an eternal loop, until we break out of it. Maybe we check some other condition inside of it, right? So maybe like, while or something. I don't know, right? So you can pretty much do everything with that. So they're like, why do we need all this other crap? Let's just stick with for, right? Like, I like that. Get rid of that other crap, right? I don't want to have to think. Well, particularly if you're learning a language, And so then you also have this one here, range, which will range over an iterable object. Iterable, you could iterate over it, iterations of it. Give me an iteratable object. So, I said object. Crap. Do they say object anywhere on this page? Name of the object, name of the object. Not a whole lot. That's an interesting question to ask. Any object. So they got it a few times. But we were talking about for. So this will go over any iteratable object right here. And so that'd be a slice. That would be a map. It could be an array. Right? And so I just want to loop over it, and it'll give me the key and the value. If it's a map, it's key and value. You could think about it that way. If it was a slice, it would give you, the key, which is just the index. So I could say, hey, index, it's position 1, position 2, position 3, position 0. The slice, or you could, even if it's an array, it's position, right? Index position 0. Or, and then the value at that position. So you could think about it key value. You could think about it index, position and value. But these are just variable names. You could call them, Tweedledee, Tweedledum, right? Whatever you want to call them. And those two variables right there. And then you could just print out, use the key and use the value. If this was a slice, I'd just say I, and that'd print what position, and then V, and that would print value. That would print, the value. So that's the for range. And so right here, I'm for ranging over the rows, and I'm going to print each row. All right, so that's just explaining sort of that setup. Open a file, read it, open a file, get a pointer to file, use reader to read it, which takes an IO reader, and file implements IO reader interface, and then take that reader and read it, read all of it, and gives me those rows. And it's rows because it's a slice of strings, right? So when I get this, I'm going to see a slice of strings, and then I'm going to run it. So let's go into change documents, Code Clinic, and then O2, and O1, and then Code Clinic O1, and then O2, and then go run main. I need to be in O1, change O1, go run main. Ooh. So that's actually kind of slow there because the terminal's slow. It takes a long time to print that to the screen. For whatever reason, prints faster here. Go run Ma. Not quite. All right. Oh, all the way to the end. It's kind of interesting. Prints faster in that one than in WebStorm. All right, so we just read a file, and you guys learned some stuff. You have any questions? You got like a
So,
shooting from the hip, fast speed tour of some cool Go stuff.
so range will just iterate over the range of values, like meaning
Yep, any iterable object, throw it in there.
function, right?
Yeah. You know, and we can play with that. It's always fun to play with things, right? So that's one of my favorite things to do and to learn a language, just to have questions. I mean, it's not necessarily the most expedient, but it's really great at teaching. Is just like, you know, hey, I want to play with something, right? So if I have, you know, a name or string, let's call it, yeah, we'll call it that. And let me go get some quote. Hemingway. That's not a good one. There we go. You know, like, what happens? I've never done this. Code points. UTF-8 code points. What? I'm going to put those back into some string. Oh, sweet. You know what I'm going to do? I got something wrong. What's it not liking? Semicolon. All right, so there's a rare instance where we have multiple statements on one line, and we got to use semicolons to let the computer know that, because it'd be way stupid to write for I equals 0, new line, I less than this, new line, right? I'm printing out UTF-8, their code points. All the different characters. And here's ASCII. So one of the things they wanted with Go is to make a language that's fun, that's fast, right? And you can see like, ooh, this is kind of agile, right? I feel kind of agile. Like I just printed all that UTF-8 stuff. That was cool. You know, it's kind of fun, you know? But I iterated over a string. What is a string? Well, let's go see what the effective Go has, or the spec has to say about it. Is a string an iterable object? String type represents the set of string values. A string value is a possibly empty sequence of bytes. Ooh, a sequence of bytes, right? Strings are immutable. Once created, it's impossible to change concept string. Pre-declared string type is a string. Interesting. It's a sequence of bytes. Let's play. All right. So this is a string. What happens if I guess I could make it a byte. I kind of like having the character, so I'll do this. And we'll just do the first 200. And we'll comment out this. Cannot convert string I, type string to type byte. But interesting try. What about this? String is a slice of bytes. Slice of butts. That's something different. Whoa. It's a slice of bytes. Which means it's an iterable object. It's a slice. Could I have casted this to a slice of byte where it's just going to be one entry in there? That's all right. Kind of weird. I'd have to sit there and think about that for a minute. That makes sense right there to me. 30, 30, 30, 31. That wasn't making sense down here. Oh, you know what that is? That's UTF-8. 4-byte encoding scheme, and the lower stuff is 1 byte. The upper stuff takes up more bytes. So one character could sometimes be represented by multiple bytes. Whoa. Dang, I'm getting into like the low-level internals of what's actually happening with UTF-8. Why? Rob Pike, Ken Thompson, Robert Gressmer were some of the dudes who created UTF-8. You know, the most popular coding scheme in the world. Why would you not want to learn a language created by the dudes who created the most popular coding schemes in the world? Really? You're going to go with a language created by some Italian guy who then broke backwards compatibility and nobody in the community followed him because he thought that the previous version 2.7 was no good? So he went to 3. And then everybody's like, no, even though you create a language, we're staying with 2, even though you don't think it's any good. You want to learn that language? I don't even know the Italian dude's name. What else has he done? He create UTF-8? He create Unix? I don't think so. He wasn't there. Did he create the C programming language? No. Right? It's like, I don't want to learn that language. That was a huge red flag for me. I started learning Python. I'm like, what do you mean the guy who created it went forward, broke backwards compatibility, and nobody followed him?
Oh.
Huge red flag.
Was Italian?
I think so. You know, which Italians are great cooks, but I'd rather have a BMW than a Ferrari, thank you. Right? It's like, you want me to be completely politically incorrect? You want to hear my completely politically incorrect joke? Of course you do. You want to hang yourself on YouTube, Todd? Go for it. I want to watch. You guys are horrible. What is it about the human mind that wants to watch people like go to their destruction? All right, so here's the joke. What is heaven? Heaven is where, let me think about this. The police are all British, and everything's engineered by the Germans. Everything's engineered by the Swiss. It's all built by the Germans. It's all cooked by the French, and your lovers are all Italian. What is hell? Hell is where the police are all German. Everything's built by the Italians. It's engineered by the French. The cooks are all British, and your lovers are all Swiss. you know, general stereotypes, and only that's all they are. They have no specific truth to individuals. But you can make broad swipes about cultures, you know. The only one I don't feel comfortable with in there, just because of Germany's history, is the Germans being militant, because they've really worked hard to sort of overcome their past, the militancy of their past. So that's the only one which I feel like is like really offensive in that joke. So I just want to tip my hat to who the German people are today, which is different than who they were, I believe. And they are the best damn engineers. My wife is a high-performance driver, and she used to have a Volvo, you know, kind of sports car. Good. I felt comfortable. She could do 80, 90 in it, and I felt all right. And then we sold that, and for a while we just had my Toyota Tacoma. I didn't feel comfortable when she's doing 85, and we're up, you know, a high center of gravity. I'm like, we got to get you a new car. And so we're just looking around. We go to the BMW dealership, and finally we're like, let's get this 528i xDrive. Badass, beautiful. You know, I was always just a Toyota person at first. I was like, let's just get a Camry, you know? And she's like, eh. And so we got that. And then after like 10 minutes on the freeway, I'm like, I want to own this car the rest of my life. Like, it's so beautiful. Like, I felt peaceful. Like, this is a work of art. Like, these people put so much craftsmanship and care into just precision, making everything work well. So, Germans, awesome engineers. And I should get a free BMW for that testimony. back to whatever the hell we were talking about. Slice of bytes, strings. So I really think that like coding, talking, and is good stuff, and we're going to continue to work through this exercise right here. But I want you guys to create a string and then print it out as a slice of bytes, and then I want you to iterate over that slice of bytes, and then I want you to create a loop, and I want you to print all of UTF-8 up through 10,000, right? Sure, why not? Or some large number. And so do that as an exercise, and it's basically what I just did here. So you can look at this if you need some examples. And you know, the only thing that's not in there is the iterating, which is this one. But you know, try not to look at the screen. Or look at it. Retyping creates muscle memory. All right, and then we'll pick up with going through this example after that.